All right, good evening, everyone, and welcome to the Annual Astronomy Slam here at the Charles W. Brown Planetarium at Ball State University. How's everyone doing this evening? Awesome. This is one of my favorite events that we host. I started it about 4 years ago. This is the fourth annual event. I am the director of the planetarium here, Dana Thompson. Again, this is my favorite event of the year, but it is one of the most stressful events. We've been working a lot for it, and we just had a partial solar eclipse happen. Did anyone come out for that? So we had a partial solar eclipse happen. The weather wasn't the best here in Muncie, but we just hosted this huge event about 4 weeks ago for that, and then we had to do Astronomy Slam right after. So this is probably the quickest turnaround that we've ever had for an Astronomy Slam Champion award ceremony and event. So it's the quickest turnaround that I've had for creating some of the visuals and putting them together based on what our presenters wanted. And it's the quickest turnaround I feel that the presenters have ever had to do. So kudos to them for really pulling it together, and great job for everyone involved here at the planetarium. And so I'm really excited to share this hard work that we've been really preparing over the last few weeks with you this evening. We have a really special guest here. Lots of special guests. We have two previous awardees or slam champions. In the back of the room, we have Nicolette. Nicolette is our new planetarium show specialist. She's been doing an amazing job in her new role here. And she has to put up with me, so even more kudos to her. But she was our Astronomy Slam champion back in 2021. She talked about exoplanets, which you'll be hearing a little bit about this evening in one of the presentations again, but with a new spin. We sometimes have repeat topics here at the planetarium, but the students always put their new and improved spin on things and make it interesting each time we get that topic again and again, like black holes. And other interesting things like constellations. We always talk about constellations. How can you make it interesting? Well, you're going to see and hear about that this evening. So we have Nicolette here helping out this evening. And then last year, we had another Astronomy Slam champion, and that's Kyrie over there on your right-hand side. Kyrie's back again. And to follow tradition, Kyrie's going to MC this event. So last year, Nicolette MC'd the event, and this year Kyrie is, and he's going to really take it over mostly from here after I do one more quick note and introduce our speakers, our presenters, our folks who are competing for Astronomy Slam Champion. But just a couple notes so that you know what you're in for this evening. One of the things that I am just remembering now, you were given a link to vote. If you did vote, that's going to get deleted because we are not going to let people vote before you see the presentations. That's not fair. So sorry. I know like some of you are like, oh man, this is the person I want to win and I know it, so I'm already voted. We're going to close the form, open it back up, and do the voting at the very end of all the presentations. So the voting link really shouldn't be active. So we'll get that switched over. But you are voting. You get to choose who is the best overall presentation, the Astronomy Slam champion. You also get to choose who had the best energy, who had the most visually engaging presentation, and whose was the most thought-provoking. So everyone's a winner here. There's trophies on the front table. There's a main one, and then there's little tiny trophies that I hand-painted with love for all the other ones. On the energy one, there's a lightning bolt. For visually engaging, there's a little eyeball. And thought-provoking, there's a light bulb, so it's in theme with the awards. Our awardees get certificates too at the end for all their work. So a lot of cool things there. What goes into planning the Astronomy Slam before I turn it over to Kyrie for introductions and for our first presenter? The Astronomy Slam presentations, they're designed by the students and written or arranged by the students. And then I take their ideas and based on what we have available on the planetarium system or what's available online, I put it together in a way that aligns with their presentation and what their comments are. So they kind of direct the presentation and the visuals and all of that, and then I assemble it based on what we can find for free online or what's on our system, just the different resources we have access to. So some people think that maybe they're designing or developing the CGI, that you'll see up on the dome. That's not necessarily the case, but they do direct it, okay? So a lot of thought is put into the visuals from the presenters, not just the content that they're talking about, okay? All right, so cool. Anything I'm missing, Nicolette? All right, I'm going to then, big round of applause for last year's Astronomy Slam Champion, Kyrie. Here we go, Kyrie.
Thank you. And before we even just start everything off, could we give another round of applause to our presenters who have came up here tonight and just really thank them for the energy, hours, and time that they put into their presentations and visuals that they're going to be showing to you tonight. But first off, just a little bit about me. Like Dana already mentioned, my name is Kyrie Standifer. I'm an astronomy major here at Ball State, and I won Astronomy Slam 2022. And so I am here as our MC and to really just bring out the best in all of our wonderful contestants here. We are going to start out by just introducing everybody who is here. So first we're going to start off with Hailey Sebring. Give a round of applause for her. No. Then we have Caleb Whitcomb. Next up, Cole Grimes. And last but not least, Maya Shelton. And I gotta say, they have a lot of courage for, standing up, because last year I was sweating in that seat, and that was not fun. But without further ado, let's just jump right into it. And I'd like to start off with a greenhorn that was highly recommended by my own academic advisor, Hailey Sebring.
So bear with me. I have to get ready real quick. So sorry. I guess in the meantime, as you know, my name is Hailey Sebring, and today I will actually be introducing and presenting about discussing some constellation patterns and their history, as well as auroras, not only on Earth, but on other planets as well. To begin, we'll look at some constellations, or really all of the constellations that we can see through our naked eye. Some of you might be wondering, well, what even is a constellation? This girl is crazy. She's starting to talk in alien. Well, I'm here to help today. Technically speaking, a constellation is a region labeled off and given a name, some correlating with mythological features and recognizable patterns. Now, I personally absolutely love the night sky and all of the constellations, but if I had to pick just one to be my favorite, it would have to be the Cassiopeia. Now, it might be because it's shaped like a W or because of the interesting story behind it. Now, Cassiopeia isn't the only constellation to actually have a story behind it, but since we are on her famous legacy, I will explain just some of her backstory. She is actually a queen of a country on the northern coast of Africa called Ethiopia in modern Greek mythology. Sorry, on Greek mythology, but please don't get it confused with actual modern Ethiopia. She was proclaimed to be more beautiful than sea nymphs, so imagine Ariel and all of her sisters on The Little Mermaid. There's way more to her story than what I've just a little bit of described, and I could go on here for days and days describing it, but that's actually not what we're here for. But now that we do know the gist of constellations and what they are, we can delve deeper into their idea of existence. In the beginning, constellations were a way for farmers to understand when to plant their crops for the absolute smallest risk of failure. They would use these cluster of stars to tell what month it is. Now, with constellations, they don't stay in a single place forever, as you can see. They appear to move and rotate because the Earth does. When winter comes around, there are different constellations than what we would see the ones in summer. These tactics were used up until the 16th century when calendars made a small debut. But of course, don't think about the paper ones that show us when all the holidays are that we use in modern days. As for modern use of constellations, astronomers use them for the naming of new and upcoming stars or planets, as well as meteor showers. It's almost like a checklist. Check, check, check. Oh, we know that one. Check. Oh, wait, that's a completely new one. Let's dive deep into her and figure out what that ball of light actually is, Now, how many people here know about zodiac constellations? I'm not going to ask any surprise questions, so you can just raise your hands. Woo! I see hands. I love that. I was preparing for no hands, absolutely. Okay, well, for the people who don't know about zodiac constellations, I'm going to help here. So they lie in a ring along the ecliptic plane. Now, the ecliptic plane is a path that the sun, moon, and planets seem to move and rotate from Earth's perspective. We use this set of constellations to pinpoint where some of the planets are, for instance, Jupiter. Now, if we peek at the west sky real quick, which is to your guys' right, we can find Jupiter just under Aries, which is just about right there. That just big ball. So, like Jupiter and Earth, they have northern lights. Scientifically, they are called auroras. They usually form when there are poles, like Earth's north and south pole, due to multiple types of storms. We start at the sun, at its core. The sun is a massive ball of plasma that inflates and heats during nuclear fusion reactions. These reactions cause solar flares and coronal mass ejections. The charged electrons and protons that escape from these solar activities travel through solar winds and collide into the Earth's magnetosphere, creating substorms. As these particles travel, they are whipped through the tail of the storms at high speeds and not so politely greet their neighbors, just like nitrogen and oxygen fragments. With these collisions, they shed off a hint of their energy and ignite color. These colors that we see in the dome are possible colors that planets can have. Now, Jupiter and Saturn have an aurora that shines in ultraviolet light, invisible to our eyes, but seen with technology. Earth has a range of colors, green, blue, violets, and reds, that we see with our eyes. And other planets like Uranus, Venus, and Mars all have different auroras based on their environments. The colors of these auroras are actually considered false colors, which are typically images that have colors that do not exactly correspond with the colors of their real counterparts. They instead demonstrate and exaggerate specific features and patterns that would be difficult to view. So imagine thermal cameras. When we look through thermal cameras, we see everyone and everything as reds and rainbows, from reds on the inside to be the heat and the outside of the colder parts being blue. Now, when we look at each other right now, we don't see those colors. We see dull, natural shades. Those rainbow colors actually represent the false color. In the early 17th century, Galileo Galilei, an astronomer and scientist, saw these amazing colors and decided to name this amazing phenomenon as the Aurora Borealis. Now, let's dive down into that name and figure out what those are. So, Aurora, we'll start that. She was both Greek and Roman, but in Greek she was known as Eros, and in Roman she was a goddess known for dawn. As the morning would arise, she would fly across the sky and announce how the sun was yet again to arrive. Now, Boreas, he was a Greek god of cold and north winds, winter, and storms, born from Aurora. Focus on Boreas, more towards those cold and north winds. They are typically where the auroras are formed, as I mentioned earlier, near the colder poles. That includes the South Pole. Although these storms are quiet the majority of the time, about 5% of the strongest auroras generate a sound that sounds close to static radio, whistles, and other uproars, approximately 62 miles above our heads. This is roughly where we consider space would be, which would be called the Kármán line. Remember those charged particles I talked about earlier? They also produce that sound we are just hearing. I don't know about you guys, but that kind of sounds like alien static. As the charged particles become trapped in our atmosphere during these colder nights, they begin to discharge at a rapid pace as the sun slams into our particles, just like the color emitted. These sounds can produce ranges of noises from like clapping noises, whistles, cackles, static, and any other sounds. Now, these sounds are rare, but when you hear them, you can definitely hear them. In 2012, Aalto University produced a theory that these sounds originated above the treetops. As they conducted experiments to prove this theory, they found that 60 of the auroras that they researched actually create the loudest sound from about 250 feet above the ground. Now, speaking of distance, did you know that the closest star in our constellations that we will see in this dome is only about 4.2 light years away. Yes, only. Now, this star has a name of Proxima Centauri and is located within the Centaurus constellation. As for the farthest star, the Tau Canis Majoris is located about 5,000 light years away and is located within the Canis Major. Now, as we fly out here, remember those stars I mentioned? Just watch as the constellations start to collapse and you can see just the reality of how far and close they are. But if you want to take a more closer and technical look at it, about 1 light year is 6 trillion miles away. Now imagine that from the largest star. Times that by 1,000. Now listen, I'm close to a math major, but that's a big number, okay? That's all I could say. But as we start to fade out here, I will just mention just a little joke that I wanted to just include. Do you guys know what an astronaut's favorite game is? Rocket League. Yeah, there we go. There are some laughs. All right. As I wrap this up, I would like to personally thank each and every one of you for coming out tonight and watching us all present. I understand sitting and lying in those extremely comfortable chairs can be very tempting to fall asleep, as I've been in your shoes once. But please at least keep one eye open for the rest of the performers, as they have a ton of information that they want to share and facts that I think will be very, very, very intriguing. But just remember tonight when you go out and if the sky's clear enough, remember just to take a look at the Muncie sky and see what is all above us. Thank you.
Come on, let's light up our dome with another round of applause for Hailey. You know, I gotta say, I can't believe the Greenhorn actually, did a presentation on the color green. Just not to call her out, look out for my mom. She may ask you a bunch of questions about the Aurora Borealis. And now, next up, we actually have a returning participant for our Astronomy Slam, so please give it up for Caleb Whitcomb.
Thank you so much, Kyrie. Appreciate that. My name is Caleb Whitcomb. I'm a grad student here at Boston University, getting my master's in physics. So, now, you likely heard of a series of books about a young wizard. These books feature potions, dragons, giant spiders, an abundance of chocolate frogs, and a young wizard who fights a dark lord. In case you may not have realized it yet, the series I'm talking about is known as the Wizarding World of Harry Potter. Now, do I have any Gryffindors here? Any Hufflepuffs? My Ravenclaw friends? How about Slytherin? Now, since tonight's show is called Astro Slam, you might be wondering, what does Harry Potter have to do with astronomy? And you'd be surprised to find out that actually has a lot. In fact, many of the characters we know from these famous books are actually based off of objects we can see in the night sky. So we'll be taking a tour through our night sky to see some of the objects and constellations which these characters' names originate. So first we have our Dark Lord's favorite Death Eater, the character of Bellatrix Lestrange. Bellatrix Lestrange, one of the most powerful and vicious witches in the Wizarding world, shares a name with a star called Bellatrix, which can be found in the constellation of Orion. Orion is a winter constellation, so it'll be much easier to be seen in the next couple months. Bellatrix in Latin means female warrior, which is a perfect name for this witch. Now, Bellatrix itself is actually pretty interesting because star Bellatrix is actually almost 4 times hotter than our own sun, at about 22,000 degrees Celsius at its surface, compared to our sun, which at its surface is about 5,500 degrees Celsius. And is actually one of the hottest stars we can see with a naked eye. Now, nearby in Orion, we also have another object which is perfect for this wicked witch. We have a cloud of gas and dust here, which is known as the Witch's Head Nebula. Now, a nebula is a term we use for a cloud of gas and dust, and the Witch's Head Nebula is actually a kind of nebula known as a reflection nebula. which basically reflects light from a nearby star, which in this nebulous case is from the star Rigel. The dust in these cloud of gas reflects blue light better than red light, which is why the nebula itself appears to be bluer in color. Now, another star, maybe you've heard of before in the constellation of Orion, is a star known as Betelgeuse, or Betelgeuse, whichever you like. Now, Betelgeuse is actually a red supergiant, which is in the later parts of his life. It is so much larger than the sun that if we were to make the sun the size of Betelgeuse, it would actually swallow all the inner planets in our solar system and be almost as large as the orbit of Jupiter itself. Now, some of you may have heard of Betelgeuse in the news a couple of years ago due to it getting noticeably dimmer in the sky, when some thought maybe it might go supernova, one of the most energetic events in the universe itself. Now, don't worry, it's not going to go supernova just yet, but when it does, it will be so bright that we could see it in the daytime sky. Now, Orion doesn't just have old stars in it, it actually has a lot of new stars in it as well. If we look towards Orion's famous belt, we can actually see a bright object below it, commonly referred to as his sword, otherwise known as the Orion Nebula. Now, the Orion Nebula is a cloud of gas and dust where new stars are being born in this stellar nursery. Now, in this stellar nursery, this is actually the closest stellar nursery to Earth at about over 1,300 light years away, which is roughly about 8 quadrillion miles away. That's pretty far away, right? Now, within the Orion Nebula is actually a cluster of small young stars, which is called trapezium. And Orion Nebula is actually one of the brightest objects we can see with the naked eye in our sky. Now, moving on from who's followers, we're going to learn more about an object that's where the character Sirius Black gets his name. Now, Sirius Black is the godfather of our titular hero, Harry Potter, but is most well known for being able to transform into a dog, which is actually a very fitting name because his namesake, the star Sirius, is commonly referred to as the dog star, and is actually in a constellation known as Canis Major, or the Big Dog. In fact, during the hottest parts of summer, the star Sirius actually rises in the pre-dawn sky before the sun, which is where we get the phrase, the dog days of summer. Now, Sirius is actually a binary star system, which is comprised of a larger main star, Sirius A, and a smaller leftover star remnant known as a white dwarf, or known as Sirius B. Now, Sirius A is actually twice as large and twice as massive as our sun, and is about 4,000 degrees hotter than our sun is. And it is actually one of the closest stars to Earth, sitting about 8.6 light years away, or 50 trillion miles. Now, there is more than just the star Sirius in the constellation of the Big Dog. We also have a couple of other interesting objects. One object is a cloud of gas, not commonly referred to as Thor's helmet, an emission nebula. It gets its name from the Norse god of thunder, Thor, which maybe many of us may have heard of from a certain movie franchise with a friend who likes to smash stuff. Now, Thor's helmet is a emission nebula, which is a kind of nebula which absorbs light energy from a nearby star and re-emits that light, which what we see right here. But there's something even more amazing happening in the constellation of the Big Dog. In fact, we can actually see two galaxies colliding with each other. Now, galaxies in our universe can collide together, and this process can take billions of years to happen. Now, when this happens, stars and gas can be flung from these galaxies, but when the galaxies merge together, it can create it can cause the gas and dust in these galaxies to actually form new stars. Now, while I would love to talk about every character in the Harry Potter universe, we only have time for one more. So, real quick, we have time for a couple of honor mentions for certain characters. First is Luna Lovegood, whose first name comes from the moon, inspired by our nearest object to Earth. Next is Lord Voldemort's mother, Merope Gaunt, whose first name comes from the star Merope in the Pleiades star cluster, often referred to as the Seven Sisters. And then the last honorable mention is Andromeda Tonks, mother of Nymphadora Tonks, and whose first name comes from both the Andromeda constellation and the galaxy in that constellation known as the Andromeda Galaxy, the closest galaxy to us, and one which we are currently on a collision course with. Now, for our final character, I have saved the best for last. The childhood enemy of the boy who lived, our good old Slytherin buddy and part-time ferret, Draco Malfoy. The name Draco comes from the constellation Draco the Dragon, which can be found in the northern sky. Now, Draco is actually a pretty fitting name for this Slytherin character because, while in Latin, Draco does mean dragon, but it also means serpent. And within the constellation of Draco the Dragon, we have a pretty cool star known as Thuban. Thuban is interesting because of something which is known as precession. Now, if we imagine the Earth to be like a top, the Earth wobbles over its period of motion around the sun as it's rotating. When this wobbling happens, it can actually cause the positions of the stars in our sky to change over a period of thousands of years, meaning that in a few thousand years from now, the stars will appear to be different position than they are today. Thuban is related to this because during the 4th to 2nd millennium BC, it was actually the North Star as opposed to the current North Star, Polaris. Now, precession itself can actually take about 26,000 years. So, in 26,000 years from now, Polaris will go from being the North Star now to being once again the North Star. Now, another object in the constellation of Draco is a nebula called the Cat's Eye Nebula, which is a planetary nebula. Now, unlike the Orion Nebula, which is where stars are being born, the Cat's Eye Nebula is actually the remnants of a dead star. So when stars, like our sun, run out of gas, the inner core expels the outer layers of gas, leaving behind the core, which becomes what is known as a white dwarf. Now, this white dwarf emits so much energy that when the outward expanding gas is hit by this energy, it re-emits it in different wavelengths of light, which we see as the colors we see right now. Now, the last object in Draco we'll explore is something that doesn't have as creative a name. It's actually called Abel 2218, which is a cluster of thousands of galaxies outside our own. Now, we think of the Milky Way galaxy as a big space, but this cluster is actually 3 billion light years away from us, and it gives us idea of the scale and structure of our universe. And actually, what's so interesting is that scientists actually use this cluster, Abel 2218, to actually determine the distance to the farthest galaxy from Earth at about 13 billion light years, which we believe to have formed not long after the Big Bang itself. Through our tour of the night sky with our friends from the Harry Potter universe, we have seen stars both new and old, clouds of gas and dust surrounding the births and deaths of stars, seen galaxies colliding, and have witnessed the scale and structure of our universe. It is the beauty of stories that in Harry Potter that can be inspired by things we see in the cosmos. So even when things look dark, we can look to the night sky above and its wonders. After all, a famous wizard once said, "Happiness can be found even in the darkest of times, when one remembers to turn on the light." Thank you.
No, I hope I don't have to cast a cheering charm on all of you to give another round of applause for Caleb Whitcomb. Man, I got to say, this is actually what I really love about Astronomy Slam, just seeing everybody's interests, because Astronomy Slam is basically its own form of art. Everyone gets to put in their own interests, what they enjoy, and you can really see that with Caleb and Hailey's very own presentations throughout this night. But of course, we have more presentations that we would love to go through. And so while they set up the mics, I will just do a quick point that make sure to keep all of your questions, put them in your head, write them down, because we will be going through those at the end, and we'll have a proper introductions of everybody, just so we don't have any biases before we see all the presentations. So, with that said, Next up, we have not the brother of Rick Grimes from Walking Dead, our very own Cole Grimes. Take it away.
Hello. Okay. Can everyone hear me good? Okay, good. My name's Cole Grimes. I am a legal studies major here at Ball State, and today I'll be your guide through the mesmerizing cosmos. I know you're thinking a law enthusiast, a legal studies major. That's a bit different. What's he doing here? But my love and passion for astronomy and the vast universe has always held me in its gravitational pull. Today we'll be discussing exoplanets. That's going to be our primary focus. You can see our solar system here: Earth, Venus, Mars, Jupiter, Mercury, etc. But what are exoplanets? Exoplanets are planets in other stellar systems that orbit stars other than our own sun. They orbit other stars. Over here you see a representation of exoplanets. They can differ in size, they can differ in composition, they can differ in orbital characteristics, all types of things. So as we think about exoplanets, I want you to think about the sheer enormity of our universe. How big our universe alone is. Now that I've got you thinking about just our universe, think about and consider the idea that there's an entire multiverse. This right here, as you can see, is our solar system, but you're going to see projected on the Planetarium dome just in a second. After this scrolls down, you're going to see pictures of the multiverse, and I'll explain that. But if you could just look at this for a second, and then I'll continue on. And this right here is our observable universe. Now, if we shrink our observable universe down even more so, the hypothetical question was something we don't know for sure, but something that's big in the scientific community, comes to mind. The question of the multiverse. The multiverse is the idea that there are independently expanding universes separate from our own, suspended in dark matter, in an infinite nothingness, really an infinite expanse. I know it sounds confusing. The multiverse has always intrigued me, though, and some people even believe that the CMB cold spot within our universe is a sign of unusual activity, that perhaps another universe is colliding into our very own universe. So the closest, this is a presentation about our universe, however. So we're going to move on. I did want to highlight the multiverse. But you're asking, what's the closest exoplanet? Where's somewhere we could maybe get to? Which even the closest exoplanets to Earth are incredibly, incredibly distant. Right behind us, up on the dome here, you see Proxima Centauri b. Proxima Centauri b is the closest exoplanet to Earth. It's 4.2 light years away. Now, when I say 4.2 light years, that really doesn't, in my opinion, put it into perspective. Translated, 4.2 light years is 24.7, or about 25 trillion miles away. Proxima Centauri b. It orbits its red dwarf star, Proxima Centauri. It completes its entire orbital period and revolution in only 11 days. Very different from Earth, where we know it's 365 days. Only 11 days orbital period. And when NASA talks about exoplanets, when we as humans talk about exoplanets, the really big curiosity is, what if these planets have life? What about the potential for extraterrestrial life? Well, unfortunately, Proxima Centauri b's proximity to its red dwarf star Proxima Centauri and the stellar radiation that Proxima Centauri b experiences probably would unfortunately make life hard to form and inhabitable on Proxima Centauri b. So where do we go to look for life then? The TRAPPIST system, the TRAPPIST-1 system, is a very good bet for life. You see the constellation of Aquarius, and we're going to zoom in now to the TRAPPIST system. So why is the TRAPPIST system such a good bet for life? That's because it has 7 Earth-sized exoplanets. And 3 of them, as you see here, letter D, letter E, and letter C are all in the habitable zone, the Goldilocks zone, which means that they're close enough to the TRAPPIST system's star. So that's planets C, D, and E of the TRAPPIST system. Really good bet to find life there. And another great planet we're going to go to, in just this right here, is Kepler 22b. Kepler 22b, I must say, the number 22, it has come in my life in a lot of different forms. My old house's lot number used to be 22. I'll graduate college at the age of 22. I graduated high school in 2022. My dad's birthday is the 22nd. And this is also the 4th Astronomy Slam. My mom's favorite number is 4, so there's some lucky numerical stuff. But we find another lucky sign with the number 22 here because Kepler 22b is close enough to its sun that it's believed that liquid water could exist. The Kepler Space Telescope found many, thousands of planets, exoplanets, but this is just one of them that could be believed to be a water-rich structure. And if it is a water-rich structure, due to the fact that Kepler 22b is in the habitable zone, by extension, it could be suitable for life. So we talk about societies advancing and exoplanets and the ability for a planet to harbor life. But let's go back to a time when the universe was a mere infant. Back to the beginning. The beginning of the universe, the first few hours of the universe, everything was in trillions and trillions of degrees. It was so hot that for the first few 100,000 years, really about the first 380,000 years. But over time, the universe was able to cool and expand. And as the universe cooled and expanded and was not those trillions of degrees that it was in the first few hours, galaxies were able to form, photons were able to bounce, and light was able to travel freely. The more the universe was able to cool and expand. And as we talk about exoplanets, you'll see a graph in a minute here. The first exoplanet was found in 1992. And 35 years ago, there were no exoplanets. All these dots that you see in the sky here, all the circles, these are different exoplanets that have been found by us Earthlings out there in space somewhere. And I think this graph is really, really important because, as you can see, you look at the late 80s, it starts at 1990, but you can look at the late 80s, there's nothing. And then in 1992, we find our first exoplanet, and you can see by year the exponential growth. Really starting around 2000, how many exoplanets we find every year has just keep going up and up and up and progressing. To nowadays, we have found over 5,000 exoplanets. And there's also the cluster there, of course, of multiple exoplanets that were discovered right there. Yes. So yeah, I bet this gives you an idea pretty much of how rapid this is all came to be. And we still have a lot more to do, and more of a frontier to explore. An planetary frontier to continue to explore.
All right, and with that said, can we give a round of applause? But it couldn't be fair if we just ended off with one when everybody else had two. So let's give another round of applause. And you know, that's another thing that I like about Astronomy Slam. You get to see so many different people just really sharing their interest in astronomy. And, you know, I love to see exoplanets again, since that's actually what my presentation was on last year. But Cole Grimes, I believe, was in the audience for the last year and decided to really, you know, be inspired and actually present and share what he knows with everybody else. And so, last but most certainly not least, the woman who just kept ringing my phone, just, you know, trying to get some extra confidence for the presentation. So please, for her and for my phone notifications, give her a warm welcome.
Well, those presentations are going to be really difficult to top, but, you know, we'll see how I do. But hello, everyone. Thank you so much for coming and listening to my presentation. So all of us have probably heard of a black hole. You've probably heard something along the lines of they'll devour everything in our galaxy, or that they're black, or if they're not black, then they're invisible. Although those statements sound really cool, none of them are actually true. In fact, black holes aren't even really black holes. So if all these common statements are myths, then what in the world is a black hole? Let me give you a better understanding of what's actually going on with a black hole. We'll start by explaining how their existence was even presented. So here we have our sun and Jupiter. The grid you see helps visualize the fabric of the cosmos, which is what scientists call space-time. In the year 1915, that one guy we know called Einstein published the theory of general relativity. According to his theory, gravity is a distortion of this space-time, essentially the three dimensions of space and time as well. This is caused by the presence of mass or energy. So, as you all can see, massive objects such as the sun and Jupiter warp and bend the fabric of space-time around them, creating a gravitational field and affecting time near the objects. Objects that are moving within the curved space-time of the massive objects follow paths that are perceived as gravitational attraction. And as you can see, the more massive an object is, the greater its influence on space-time is. Now, what if there existed an object so massive that the curvature of space-time became so intense that it creates this gravitational well, which nothing, not even light, could escape? These type of objects do exist, and they are what were eventually called black holes. Now, up to this point, I've shared theoretical predictions with you, but predictions alone are just predictions. However, over the years, there have been compelling evidence that supports Einstein's predictions. In fact, we have tangible, direct observations that confirm his theories. This work involves studying the motion of stars, identifying patterns that suggest the influence of an unseen massive object, and estimating the mass of that object using the laws of motion and gravity. This process allows astronomers to identify potential black hole candidates and get insights into the nature of these mysterious cosmic objects. Now, let's take a look at one of the systems. So, Cygnus X1 contains the first black hole discovered. Cygnus X1 is a binary star system that is also located in the constellation Cygnus, which is also known as the Swan. Within this system, there's a massive star and a compact object, which is believed to be a black hole. Cygnus X1 emits a whole bunch of X-ray radiation. Cygnus X1 was detected through X-ray emissions. during a sounding rocket experiment in 1964. On the Aerobee rocket, there were 2 Geiger counters, which are devices that can detect these X-rays. The detectors picked up on a strong source of X-ray emission in Cygnus, and optical observations were then used to estimate the mass of the companion star, revealing it to be a massive blue supergiant. The mass of the unseen compact object was determined to be much greater than 2.9 solar masses, which is the limit for a neutron star. As the core of massive stars collapse, protons and electrons get crushed together and form a neutron. This led to the strong suggestion that Cygnus X1 contained a black hole and wasn't a neutron star. The characteristics were consistent with the presence of a stellar mass black hole. So, now that we've seen the evidence of their existence, let's try to unravel what in the universe black holes really are. So you might know or remember that when a great amount of matter is compacted into a small area, this creates a gravitational field so intense that basically no radiation or matter can escape. But there's a little bit more to that. Black holes must emit some radiation in order to be observed in X-ray, and it's possible for objects to orbit around them safely. However, once that object gets close enough to the event horizon, it'll begin to get pulled to the point of no return, becoming spaghettified. The event horizon defines the boundary where the escape velocity exceeds the speed of light. Now, the escape velocity is the required velocity of an object needed to escape the gravitational attraction of another object, in this case, the event horizon. Einstein's theory of special relativity tells us that no signal can exceed the speed of light, which is 300 million meters per second in space. Since the escape velocity of the event horizon is greater than the speed of light, this makes it cosmically impossible for anything to escape its gravitational attraction. Now, the size of the event horizon depends on the mass of the black hole. How massive can they really get? Did you guys know that there's actually different types of black holes? So we have stellar black holes, intermediate black holes, and supermassive black holes. Stellar black holes tend to be from about 3 to 10 times more massive than the sun. This means they're significantly bigger than our sun. Intermediate black holes are estimated to be closer to 100 times greater than the mass of our sun. However, intermediate black holes are the rarest type. It is inferred that if we can understand intermediate black holes more, it'll lead to a better understanding of how supermassive black holes are formed. And I'll tell y'all a little bit more about that a little later in my presentation. And now supermassive black holes are the largest type of black hole. To give you all an idea of how massive they can be, the sun is 1 solar mass, and supermassive black holes can range from millions to billions of solar masses. So this means they can be at least 1 billion times greater than our sun. The most massive observed supermassive black hole so far is Ton 618, which is what you see here. There are at least 100 billion in our universe, with one theorized to be at the center of each galaxy. But what about our galaxy, the Milky Way? There is, in fact, a supermassive black hole at the center of our galaxy called Sagittarius A star. It was discovered on February 13th and 14th in 1974 by astronomers Bruce Ballack and Robert Brown using the baseline interferometer of the National Radio Astronomy Observatory. Now, an interferometer is a tool used by astronomers to measure the angular diameters of stars and binary star orbits. Sagittarius A star's name comes from its location in our galaxy. It's located within the constellation Sagittarius. We even have an image of it thanks to the Event Horizon Telescope. The Event Horizon Telescope linked together 8 existing radio observatories to create a virtual telescope. Sagittarius A was observed for multiple nights, collecting long exposures, which allowed this supermassive black hole to be imaged. And this image was actually released on May 12, 2022. Now, with these images, we can see the predicted structure of a black hole is observed. So in the accretion disk, we see the effects of Doppler beaming, which is gas that is moving towards us and makes one side appear brighter. The event horizon, like mentioned a little earlier, is the black hole's surface, and it defines the boundary where the escape velocity exceeds the speed of light. The photon sphere is where a photon could, in theory, safely orbit a black hole. And the singularity is the center of a black hole where objects should not be able to escape. So, we've seen visuals of supermassive black holes and talked about its structure, but how are they even formed? So, most black holes are formed from the remnants of stars that have died in a supernova explosion. So, when a massive star dies, a small, dense remnant core is left behind. If this core is about 3 times the mass of our sun, the force of gravity overtakes all other forces and forms a stellar black hole. Now, the exact formation of a supermassive black hole still isn't known, but there are some theories. One of them is called the direct collapse theory. This theory suggests that premortal clouds of interstellar gas collapse under self-gravity to form supermassive stars, which then form into supermassive black holes. However, previous studies have shown that direct collapse only works with gases which consist of hydrogen and helium. Once you introduce heavier elements, the gas dynamic changes and it causes the collapsing gas to break into smaller clouds, which then won't form into like the supermassive stars. And if we don't get the supermassive stars, then it won't form into a supermassive black hole. Now that we know what supermassive black holes are all about, why do they even matter to us? Supermassive black holes in general, and black holes in general, play a huge role in the life of galaxies. Jets and outflows of gas occur, and this spreads atoms throughout our galaxy. This can boost the creation of things such as stars, and this is why it's such an important area of study in astronomy. And I know what you guys are thinking. What about our sun? Our sun will not turn into a black hole. The demise of our sun will occur in about 5 billion years, so that's great. But it will turn into a red giant, which is kind of bad news, but that phase will last for about a billion more years, and then after that, it'll enter the last phase of its life and lead to a planetary nebula. But, it's fine. We still have 5 billion years. But that is all I have. Thank you so much for listening.
All right, and now let's see Maya's gravitational pull, and let's give her another round of applause into her orbit. And audience, I just gotta ask, did y'all have fun tonight? Yeah. Did y'all learn a lot about space? So why are y'all so quiet? Please give another round of applause for everybody who decided to come up tonight.
Okay, so how is this going to work? We have the voting form reopened, and the responses have been cleared. So if you did vote, please vote again. Only one vote per person from here on out, please. And then we have a lot of people probably asking questions. One of them might be, can we vote paper and pen way? And yeah, absolutely. Miss Nicolette back here has some writing utensils if you need one, and you just use your brochure. We just do it by the honor system. If you vote online, please do not do the brochure in addition to that. We do kind of keep track of it just with sheer numbers. We understand how many people are in the room. Obviously, we can't have 200 votes if there's only 140 of you in here. So yeah, vote online. If you need a paper and pen vote, raise your hand, and Nicolette will bring one around. Kyrie, you can help with that too. So Nicolette, do you have some to Kyrie for him to help out? We can speed this up and then get to the food out in the lobby. Oh, and the awards, which is kind of important, right? So we'll get to the awards as soon as we get everything tallied up. I see 18 votes coming through. That's awesome. 20. You can vote for the same person twice. So if you really want someone to get an award, I would suggest voting for that same person all the way through.
All right, and before we take it off with the Q&A, let's first get ourselves a real proper introduction of all of our contestants here. So, starting it off.
Well, as you guys know from the first presentation, my name is Hailey Sebring. I have a couple nicknames, Hailey or Sebring. I can also go by my middle name, Jade. And then I am majoring in physics and pre-engineering with a minor in astrophysics. And compared to all of the contestants here, I am a baby. I am a freshman. So, yes. And next.
Hello everyone, my name is Whitcomb. I am, as I might have heard before, I'm a grad student here at Boston University in the physics department. I I'm a grad student. Works with the planetarium. I've worked with the planetarium here for the last few years. It's been an awesome experience, you know. But I'm getting my master's here at Ball State, and hopefully things good things in the future. So.
As we transition from Caleb to Cole, if anyone still needs a piece of paper, please raise your hand and I gladly will give you a piece of paper. Or if you have a pen, or you need a pen, I will gladly give you a pen as well.
Hello. My name's Cole. I'm a sophomore here. This is my second year at Ball State. As I said during my presentation, I'm doing legal studies. I look forward to the Q&A.
Hi everyone. I hope you can hear me. I'm bad with microphones, but I'm Maya. I'm a senior here at Ball State. I also work here in the planetarium, and I'm majoring in astronomy. So yeah, I also do art. Yeah.
And of course, I know you've been all holding on to your dying questions, really wanting to learn a bit more about science. So with that started, me and Nicolette will go around the room, passing around the microphones, and we can start off from there and start our Q&A.
Usually when you start presenting in anything, whether it's in a classroom or in a competition such as this one, you tend to have a lot of nervous energy. But I find that after I'm done performing, that nervous energy tends to go away almost immediately after I'm done. It goes from an overwhelming amount to nothing at all. So my question to my presenters are, did you feel the same way or are you still nervous?
Oh, you're crazy if you think I'm not nervous now. I'm waiting for all those questions to pop up. When I tell you I did extensive research just so I could answer some of y'all's questions, just be prepared. But yes, I am definitely still nervous.
In my case, if you saw me before the show, especially before she was done with her presentation, I was almost a sweaty mess. So, but immediately after I was done with my presentation, like I felt like I'd gone from being in the hot sun to being in wintertime. So that's and like within like 2 seconds. So like so I feel a lot more chill now, but a little nervous, but I feel a lot better. So.
I wouldn't say I'm nervous. I'm pretty calm at this point, but I would say, you know, when you finish something, you think, how could I have done that differently? What could have I said a little bit differently? And maybe I'd add a little bit more information, like that the TRAPPIST system was 39 light years away. I don't think I mentioned that.
So I guess if you know me, you know, I was definitely freaking out the whole planning process, you know, during the presentation too. But once I started talking about like the demise of our sun, I don't know, I felt calmer and I think I'm okay now, so.
Thank you so much to our lovely presenters. All right, audience, so if you do have a question, please raise your hand really high in the sky and then tell me which person you would like to direct it to. Or better yet, you can say it into the mic because the presenters need to know who their question is towards.
And I'll start it off with this one here.
My question is for Cole Grimes. My question is, when I looked at the data sheet of exoplanet discoveries that you put out, there were two big jumps between 2010 and 2020. What were those?
Well, I don't want to give any misleading information, but if we're saying the increase began at 2020, I would believe that a big, part of that would be the James Webb Space Telescope, maybe, that went out in 2021, has really been able to enhance our ability to detect exoplanets and go back to the farthest regions, the very first galaxies to ever form in space.
Thank you so much. We have another friend in our audience here.
I also have a question for you, Cole. I was curious about the Kepler 22b. Is that what it's called? Kepler 22b. How far is that from us or where is it in relation to where we are?
Well, I'm not sure if I can say the exact light year distance for Kepler 22b. I think I do know it's further away than both Proxima Centauri b, which is 4.2 light years, and it's also further away than the 3 habitable planets in the TRAPPIST system. That's 39 light years away. So
Kepler 22b is a little bit farther than that at 620
Okay.
light years away.
okay.
All right, are there any other questions? Oop, I see someone over on this side with their hand raised high. Thank you. I'm making my way over.
Hi, my question is for Maya. I want to make sure I'm using the right scientific term. But when things go into a black hole and get spaghettified, where do they come out, or do they come out?
So from my understanding, no, they don't come out. They're just, yeah, they're gone for good. I hope that's a good answer for you.
I see a young man in the audience who has a question. Pardon my reach, I'm going to have to pass the mic. Can you help me, sir? Thank you very much.
So this is from Maya. So like when the sun will like come closer and closer to the earth, does it like happen eventually over time, or will it just like, so there's a period of time after this where it will just keep going, or will it just keep coming slower and slower right now?
So I believe you're talking about like when it turns into a red giant. I believe it'll take about 8 minutes for us on Earth to notice that. I think that's a rough estimate, but yeah, that's the time period from that. And then once it's turned into a red giant, it'll stay that way for about 1 billion more years. So I hope that gives you a good time scale.
That is definitely billions and billions of years from now. Please keep that in mind. That is not a tomorrow problem. That is not in the next century problem. That is not even the next million years problem. It is 1 billion years from now. So all of our friends in the audience who might be panicking, don't worry. We're all okay.
But hey, if it does happen, we'll make sure to tell you.
This question is for Hailey. I had no idea that we had southern lights, so I appreciate that. My question for you is, what color are they?
Give me a second while I find the answer. Because I have it in here. I just have so many.
We love that our presenters are so prepared. Thank you.
Oh, you're welcome. Okay, I found it. I'm so sorry for the jump scare if I scared anybody. So, the colors really depend on the atmospheric gas that the particles collide with. So, oxygen, like Earth, they usually have an aurora of like green and red. And then other planets that have like nitrogen as their main like atmospheric gas usually give off like blue and purplish colors.
Before we ask any more questions, I would just like to let everyone know that if you would like to give your pen back, and we would love our pens and pencils back, please give them to someone in a purple shirt. They will be walking around and taking your pens and pencils back. But we have another friend in the audience who has a question.
This is for Hailey as well. To follow up with that, will we be able to see those lights at some time in the future here in Indiana?
Give me a second while I find that question, because I did have that as well. But I do know, actually, we can end up and see the colors of the auroras in... It's actually been found that of 2 auroras that we could see in Florida as well, which is pretty south. There were 2 occasions. There was one in 1941 and another one in 1989, which is about a 48-year difference. So in that path, it's about 2025 to 2030 2030 that we will be able to see another one roughly in Florida. But that also depends on the fact of the atmospheric like temperature, because it has to have a colder temperature of it. And although they are mid-range down to the equator, they don't occur at the equator just because of the warmth. So like right now in the southern hemisphere, during the like at the South Pole, we can't see the auroras just because it's summertime there. But since it's almost winter here, which I know most people probably don't like, we will be able to see the auroras. Does that answer your question? Okay.
We have another question.
Hi, this question is for everybody. Is there a specific memory that you have when you were like, okay, I want to study astronomy more and more?
Well, I personally love math, so I love calculating different types of equations. It's like a fun obsession of mine. So like even when I'm like bored, I do math equations. But I like the fact that we can try to figure out new planets that we can live on. At least a possibility, because we know this Earth will not last probably forever. So I like the fact that I can probably calculate that, which is why I'm planning into going into aerospace engineering, so I can figure out calculations on how to get rockets into the air and figure out if we can maybe we can go to Mercury, even though it's like probably impossible to touch it because of how warm it is, or maybe we can go outside of our solar system. So yes, exoplanets.
Now, for me, those who know me, like my mother here in the audience tonight, know that I've very young age. I've always, I loved astronomy, loved learning about space. One of my gifts as a kid was like a little toy that based off the movie E.T., which told you information about all the planets. But the event that really got me to study astronomy was a few years back. If any maybe remember 2017 with the Great American Eclipse and the resulting Great American Traffic Jam. So I had heard at the time before the eclipse, I was at a bit of a weird place, and I learned about the eclipse. I was like, I've always wanted to see an eclipse, so I should go see it. And so I convinced my mother and a friend for us to all go down to the Kentucky eclipse, and there is no other experience than like seeing totality of a solar eclipse. For me, it was a life-changing moment. It was then I maybe really want to study astronomy, and that actually led me here to Ball State. So it was quite an amazing experience.
I think, when I was young, I personally had kind of, maybe a bit of an interest in space and drawing myself as an astronaut and things like that. But where I guess this interest really came to me was when I was around 14 and 15, and my friend Jace, who's really into science but more into paleontology, we would go to our local library, and we would read books by Neil deGrasse Tyson, Michio Kaku, and all types of books by different astrophysicists. And that was really where my interest stemmed from, reading those books in the library.
So I have kind of a specific memory. I don't know how old I was, but I was laying in my bed one day, and I glanced out the window, and it looked like the stars had like a smiley face. And I was like, oh, and ever since then, I just was always interested in the night sky. I didn't really realize that was astronomy or what astronomy was. But then, I got to high school, and they actually offered an astronomy course, and they actually had a small planetarium. And after that, I was like, oh, wow, this is really cool. And I was actually going to do aerospace engineering, but I don't know, I realized I wasn't huge on engineering, and I just had to go back to my roots. And also, I just think it's such a work of art, like space, and I love art and stuff. And I love how there's a lot that's unknown about it. Like the other sciences, like biology and stuff like that, it's very difficult as well, and chemistry, but it's like we have all that stuff here. We can already see it, we can study it, but in space, it's like, I don't know, I love the mystery of it.
Since our lovely friend in the audience said everybody, I actually have encouraged Kyrie and I to answer the said question as well. To keep a long story short, it started when I was 10 years old. My sister and I, she is my older sister, we have 9.5 years between us. So around the time that I was in elementary school and just a wee child, she was entering high school. Huge generational difference. And we bonded together by stargazing together every night after she left high school or she was done for the day. She'd come back, come get me, and we would stargaze together to find a way to bond. And I kept asking her thousands and thousands of questions until eventually I hit some that were too complicated for her to answer, especially since she's not a math or science person, she's more of an English person. And I eventually went to my mom and asked her some questions, and she didn't have the answers to them either. And that led me to college to find the answers that I was looking for, and now this job. And now all the questions that I had when I was young, I can answer them for all of you.
And then last but certainly not least, we have me here. My story starts back from elementary school. My mom can recount it perfectly. One of our science teachers hosted something called an astronomy night, where he would bring his own telescope, and he would basically invite all of our class members to go out there and actually look up at the night sky. And of course, when I heard about this, I heard that it was in the playground. So me and my friends, we all came up with a ploy in order to convince our parents to bring us to school so we can go to astronomy night under the guise that we could play at the playground. Quick to say that, my mom did not allow that. And from there, she made me really go to the telescope. And she made me go to the telescope. And after I looked through it, I was mesmerized. I couldn't leave it. I was by his side constantly throughout the entire night asking so many different questions. And that basically leads to where I am now. And so with that said, I know that all of you have had a great time, but unfortunately our contestants still have high nerves. And because they're trying to figure out who's the overall winner of our good old Astronomy Slam. And so, before we start off, can we just give another round of applause for everybody? And let's get started with the awards. The award to most thought-provoking goes to Cole Grimes. All right. Let's have another drum roll, please. Next up, the winner of Best Visuals goes to Caleb Whitcomb. All right. Another drum roll. The award for Best Energy goes to Hailey Sebring. And now a big drum roll. The winner for this year's Astronomy Slam of 2023 goes to Maya Shelton.
Woo! All right. Great job, everyone. And thank you all so much for coming out to the 4th Annual Astronomy Slam. We will do this again next year. We already have the trophy. We have to.